Okay, relative velocity 2019, question 2, part A. The question reads, a man walks at constant speed of 4 kilometers an hour and he's going west to east. So this is, you know, straight away that's 4I going in that direction and no J's, and we know we're dealing with vectors and relative velocity. The wind appears to the man to come from a direction north 50 degrees east, north 50 degrees east. So let's set up a diagram for that. The man is going in this direction. Better straight line than that required. The man is going in this direction and the wind appears to be coming from this direction. I need to set up my I and J axis. I have the man on the I axis, so the wind appears to come at an angle of 50 degrees. That would make that one 50 in here. We can create a right angle with my I down the bottom here. So this is my I direction. And this is my J direction for the wind. So we'll just use the angle 50. We could put a 40 in here and use this angle here as well. So the velocity of the wind relative to the man, let's call the speed of it u, and we can see in this sector here, it's going in this direction, so it's a minus direction. So just write that. The velocity of man is 4I plus 0J. The velocity of the wind relative to the man, we'll call it u, minus u. Now in the I direction, I is opposite 50, so minus u sine 50 times I. We could use cos 40, and we know cos 40 is the same as sine 50, and it's going to be minus u. And in the J direction, J is adjacent to 50, so minus u cos 50 times J. We also know that the velocity of the wind relative to man is equal to the velocity of the wind plus the velocity of the man. Now in this question, we're asked to find the magnitude and direction of the velocity of the wind. So we want to isolate the velocity of the wind. The velocity of the wind, obviously minus here, not a plus and minus. The velocity of the wind is equal to the velocity of the wind relative to the man plus the velocity of the man. So if we fill those in, the velocity of the wind is equal to, just add the two together. So we have the two I's together, 4 minus u sine 50 times I. And we just have minus u cos 50 times J. So that's the vectors in relationship, the man and the wind. Now let's see the woman and the wind. So the woman at the same time is walking in the direction north 40 degrees west. Okay, north 40 degrees west, northwest. So she's going in this direction here. It's the velocity of the woman. I'll do WO so we don't confuse it with the velocity of the wind. The velocity of woman, she's going that way, 40 degrees. I could set up my I and J vectors along here. So in that direction is my I component, and in this direction is my J component. What else does it tell us? She notices the wind appears to come from the north. So the velocity of the wind relative to the woman is from the north. So just coming down this line here, down in this direction. So that's a minus, it's coming down, and it's a minus J, so it's equal to 0I. And we'll call that V this time, the velocity of the wind, minus V times J. Okay, what about the woman? We're told the woman is also walking at 4 kilometers an hour. So the velocity of the woman. Now, what sector is this over here? This is minus I plus J. So we're going minus plus. So she's walking at 4, so minus 4. And if we look at our I component, it's opposite the 40, so that's sine, minus 4 sine 40 times I, and positive J plus, and we can see that J is adjacent to the 40 degree angle, so plus 4 cos 40 times J. Now we have a number here, 4 cos 40 is a number, so that should help us simplify things down in a minute. So that's the velocity of the woman. Let me just put a note there. So the velocity of the wind is these two added together. So we have minus 4 sine 40 times I plus 4 cos 40 minus V times J. So if we equate the two velocity of the winds, the I component here is definitely just a number, minus 4 sine 40. And the I component up here just has one unknown U, so we'd definitely be able to find U straight away by just equating these two things. So minus 4 sine 40 is equal to 4 minus U sine 50. So fiddling around with these, we're going to get 4 plus 4 sine 40. The minus U sine 50 will go to the left, and then we'll divide by sine 50 to get U. So U is equal to, a calculator, 8.578. Because we have U, we can now get the second part of the wind. We don't actually need to worry about the V. So minus U cos 50 minus U cos 50 minus 8.578 cos 50 is equal to minus 5.5138514. So the velocity of the wind is equal to 8. That's my U. 8 is my U, but the I component of the wind is minus 4 sine 40. Type that into a calculator, minus 4 sine 40 minus 2.57 I. And then we've worked out our J, minus 5.514 times J. Now what are we asked? We're asked for the magnitude and direction of the velocity of the wind. So let's get the magnitude of the velocity of the wind. It's just Pythagoras really. Square these two things. 2.57 squared plus 5.514 squared. That's going to give us 6.08 ms to the minus 1. That's the magnitude. And the angle, we asked for the direction. The direction is the y component, the tan of the y component over the x component. So the tan, the angle of the wind is equal to the tan, or the inverse tan of this, 5.514 over 2.57. And if we type that into a calculator,